Welcome to clickmyproject.com. Let me discuss about the project Spine Image Fusion via graph cuts. Let me discuss the concept of the project Spine Image Fusion via graph cuts. In this project, we investigate a novel CTMR spine image fusion algorithm that is based on FCM. FCM means fuzzy scene means clustering is used to segment the CT and MR image. Before that, we perform fusion of CT and MR images. We collect CT and MR images of same person, scan reports that provide useful soft tissue details including the spinal disc, nerve, cerebral, spinal fluid and spinal cord images. Introduction of this result is used to fusion of images that is helpful to physicians. FCM based method result depicts sharp MR and CT details. CT images depict bony detailed structures, especially the bone correct, allowing the assessment of the damaged joints or osteogenetic growth. Spine image fusion result is the best result. FCM increases the accuracy of segmentation. We use both CT and MRI scan results of same person. This fusion helps to physician to access the soft tissue details. We perform the registration process initially, that is resize the CT and MRI images to fuse the images. Fused details are used to get the bone details and other details from the given CT images. CT and MRI given that provide the separate details from the project. We get the bone details separately and fused clustered images are retrieved from the segmentation process. Let me discuss the flow of the project Spine Image Fusion via graph cuts. In this project, we input CT and MR reports, scan reports separately. Inputted CD and MR report scan report images are performing the pre-processing. Before that pre-processing, we performing the registration phase. Registration phase in the sense we resize the image into 256 cross 256 values. Resize the images of performing the pre-processing step. Pre-processing step is the basic step in the image processing concept. Image processing performing pre-processing step to remove the noise from the given image. Noises in the CT and MRI images are removed by Gaussian filter. Gaussian filter removes the noise pixel and gives the denoised image for the other process. After that pre-processing, we performing the histogram process. Taking histogram for the CT and MRI images is used to performing the threshold point to segment the images. Histogram equalized images are displayed. Histogram equalization in this histogram is calculated and displayed. After that, we performing the fusion process in the sense that is done by FCM. FCM used to segment and fuse the images used to performing the segmentation process. Basic fusion is performed for in this CT and MRI images. Fused images is further used for segmentation. FCM segmentation segment the images. We give the cluster points into 2 to 3 cluster positions. The clustered segmentation images are displayed in separate figure window. The segmentation images are used and we perform the bone detail from the segmented image. We get the segmented image based on the histogram. Histogram value is used to segment the image. Segmented images used for physician to analyze the bone details.
Let me see the running procedure of the project Spine Image Fusion via graph cut. Right click on the main.m file and press run file button to run this project. This execution window shows the design. Initially, I am inserted 1 to 4 persons CT/MRI image. If I am pressing the first option button, it shows the CT and MRI of the first person scan report. This is a CT image and this is the MRI image. CT image is displayed in the first axis and the MRI image is displayed in the next axis. We performing the fusion for this two CT and MRI images. Then we shows the histogram for this CT and MRI images. This is a histogram of CT images, that is denoted by red color, and this is the MR images histogram, that is denoted by blue color. Then we calculate the pre-processing process. We use the Gaussian filtering to remove the noisy pixels, and we shows the pre-processed CT image in the first axis and pre-processed MR image in the second axis. After that, we perform the fusion process by pressing the fusion button. These two images fused together and displays in the third axis, that consists CT and MR images, and the two image values are displayed. Then we perform the segmentation, that is done by FCM clustering, that is fuzzy means clustering. Fuzzy Z-means clustering is performed for this fused images. The fused image is used for segmentation. By segmentation, I am using the 2 to 3 clustering positions that displays the segmented image in the new figure. This new figure displays the segmented images. Thus the 2 to 3 segmentation. The final segmentation displays the cluster, and the third segmentation displays the separate values, and first image is the fused value, and the second image is also display the first cluster and the second cluster and the third cluster values. After that, we can see the segmented bone details and other skull details. Bone detail and skull details are different in the separate window. And this is the bone detail from the given image. It clearly displays the bone detail from the fused images. Fused image bone details are displayed using the threshold value. This is get by the histogram of the given images, and also it displayed the skull details. The soft tissue details is displayed in the figure 5. Figure 4 displays the bone detail. Figure 5 displays the tissue detail. The tissues in the given fused images displayed in the figure 5. Thank you.